Alright, so now we will try to learn how to sketch a pressure distance graph. Okay, so for pressure distance graph, same thing. We are looking at three types of particles. So the very first particle will be known as the compression. So for compression wise, the pressure will be the greatest. Okay, the second particle that we're interested in is actually the rarer fraction. So rarer fraction is where the the pressure is the lowest, right? Then after that, the third particle that we are interested is the particle at the maximum displacement, or what we call amplitude. So just put particle at amplitude. Alright. Okay, so what is the pressure of the particle at amplitude is actually equal to ATM, which is the atmospheric pressure, or you can also think of it as the pressure at equilibrium, which is the so-called this part of the graph. Right. Okay, so let's sketch the graph together. Okay, so if you look at the yellow color shaded region, which is known as your compression, right? So the compression is definitely at the maximum. Alright, then after that, rarer fraction will be at minimum, or the minimum here. Okay, after that will be compression again, right? So compression is right here. Okay, next will be rarer fraction again, minimum. Next will be compression, which is right here. Then of course rarer fraction. The last will be compression. Alright, so after labeling all the compression and rarefaction, right? Okay, so let me just shade first. After that, green, rarer. Okay, after that, we will need to label the pressure of the particle at the amplitude. So this one is just at the atmospheric pressure, or what we call the equilibrium pressure. So just label right here. So this will be here. Right. After that, the second, okay, so the second particle will also be at here, right? After that, third particle will be here. Then after that, fourth particle will be here. And last, the fifth particle will be right here. Okay. Okay, so I think did I miss out any? Okay, I think I miss out a point. Yeah, I miss out amplitude. Okay, so I miss out one of the amplitude is right here. So it's this, right? Okay, so this will be right here. Yeah, alright. So this is all the pressure, all the particles at the amplitude. Then after that, you just need to sketch. Just need to join the dots. So you join the dots. Okay, roughly like that. Alright, so that is how you draw the pressure distance graph of the sound particles. Right? Okay, so of course, let's do a very quick summary. So for compression wise, okay, so we are interested in the three particles, right? So compression, we know that the displacement from the EQM, so displacement is always respect to some reference point. So for us, for physics, right, we always talk about EQM. So displacement from EQM is equal to 0. So of course the second is the pressure. So pressure must be greater. Pressure is greater than ATM. Okay, so for second will be rarer fraction. So rarefaction has a very similar displacement, right, as compression, which is 0. So displacement from EQM is 0. Then second will be pressure. So pressure will be lesser than ATM, the atmospheric pressure. So just to elaborate, right? So atmospheric pressure is 1 multiplied by 10⁵ Pascal. So for compression, right, maybe the pressure is about 1.5 times 10 to the power 5. Rarefaction maybe 0.5 times 10 to the power 5 Pascal. Alright, so okay, then third will be the particle at amplitude. Okay, So okay, so for the particle at amplitude, the displacement is equal to maximum. Okay, of course the second will be pressure, so the pressure will be equal to ATM. Alright, so these are the three particles that we are interested in sound topic.